Hi everyone, I hope we're all doing well. So yeah, I'll start the presentation on fluvial modeling, unpacking techniques and applications, but really we're going to be looking specifically at 1D and 2D flood modeling. So if we just start with a quick agenda, like I said at the start, this lunch and learn will focus on 1D and 2D river modeling, but Flood Modeler also does different types of modeling like urban drainage and coastal, but today we'll just cover fluvial modeling. So we're going to have a quick look at why we actually build fluvial models. We're going to take a look through the flood modeling process and what a typical fluvial modeling process might look like. And then we're going to go a bit into the technical detail of what 1D fluvial modeling is, what 2D fluvial modeling is, and what a linked 1D, 2D modeling approach would look like. And then at the end, we're going to head into a bit of a live demo just to show you what the Flood Modeler software looks like in an example case study. So if we start off with what is fluvial flood modeling, so like any type of modeling really, fluvial modeling approximates real world processes. So what we're trying to do is get a good representation of the real world into a model format. And I think this is a really nice, simple definition of what fluvial modeling actually is. So fluvial modeling uses predicted river flows and rainfall combined with topographic data, so that might be from LiDAR or survey, and flow equations to generate flood risk information such as depth, velocity, flood levels, and hazard. And they're the really key things what we look at with flood modeling is the outputs, because they help us to inform the things we want to use fluvial modeling data for. So if we quickly go into why we build fluvial models, so flood risk management involves a range of interacting activities that aim to reduce flood risk, and fluvial flood modeling underpins so many of these. Um, from flood warnings and flood incident management and trying to predict when floods are going to happen, that might inform people that need to use property flood resilience measures like floodgates, or the Environment Agency putting up temporary defences. Um, it's really useful for spatial planning and community awareness. So if we want to build a new housing development, we need to know what the flood risk of the site is and how we're going to mitigate it. Again, we can use fluvial modeling to do this. And also for appraisal and cost benefit analysis of new big schemes like tidal barriers, new flood defences, to work out what is the benefit we're going to get from building these flood defences. All of these things will be underpinned by fluvial flood modelling. So I'm just going to quickly run you through now a typical process that we'd undergo during a fluvial modelling project. So the webinar today is mainly going to cover number one, which is selecting the best modeling approach. And that would usually be our first step during any project. What do we need to do and how do we need to do it? Then we'd look at collecting data. So that might be survey, that might be inputs into the model in terms of the fluvial inflows or rainfall. And we're really lucky in the UK, especially, that we have loads of gauging stations which can be accessed via Flood Modelers Hydrology Plus. Really detailed LiDAR data across the whole country, and loads of other bits and bobs that you can access. Once we've selected our approach and got our data, we'll start the model build process. So this is physically building the model in the Flood Modeler software, getting all our survey information into the model and building the model. What we'll then do is test, calibrate, and validate. So what this is doing is trying to really fine tune our model to match what we see in real life. So this could be in the 1D via gauging stations that have real-time data, so we can fine tune our model to try and match that. Or we can even do that in the 2D with observed flood extents and that type of thing. And then what we'll do is our model runs. So that might be running a full suite of events for a defended scenario or an undefended scenario. Maybe we need to do some breach runs. And then what we'll do is we'll quality assure that to make sure that we're happy with the model build, we're happy with the representation of all the structures, and then we can send that over to the client. But as I said, today we're really going to focus on number one, which is selecting the best modeling approach. So there's just a few things here I want you all to consider when you are selecting the best modeling approach, because obviously, as we're going to come across, there's a lot of ways to do this and a lot of different ways to reach the same goal. So the first one that's really important is looking at what is the objective of the study. Are we building a flood forecasting model? Is it for a flood risk assessment for a housing site? knowing what the objective of the study is really important to determine what type of flood model we want to build. The next one are what are the flood characteristics? So are we in a really steep catchment? Is it a really shallow catchment? Is there a tidal influence? That's also really important to determine what type of model you want to build. The next one, which links to some of the training that we've got coming up, is what skills do we have? If we need to build a flood forecasting model, do we have skills in our team? Do we have people that have built those models before? What data is available is also really important. Do we have survey? Do we have an incoming model? How old is it? Do we have the available topographic survey and LiDAR that we need? Do we need to go out and collect some more? So that's also really important when you're starting off a fluvial modeling project. And also, what is the budget for the project and how much time do we have? You can spend as long as you want fine tuning hydraulic models to get the best representation of real world conditions as you can. But in reality, you might not have the time or the budget to build that. So sometimes you need to build the best you can with the data that you've got. Also, really complicated flood models take a lot of time to put together. So that's another thing you might want to consider. So if we quickly go now into some of the more technical stuff, and we'll start off with what is 1D flood modeling. So put simply, 1D flood modeling solves the 1D equations of flow in channel. They're typically looking at the conservation of mass and momentum. In Flood Modeler, you have various different nodes or cross sections, and the model will basically calculate a water level, velocity, and flow rate at each node, and then pass it on to the next one in the system. Flood Modeler also has the most comprehensive range of hydraulic structures and point structures, such as weirs, bridges, sluices, manholes, all that orifice units, all that type of thing. So we can really pick the units we need for our flood modeling study. And what I've wanted to do here is just do a quick example of what it looks like for someone going out on site and surveying a cross section or a bridge, and then what that looks like in the flood modeling software. So what I'm going to do now in the next section of this webinar is really just take you through 1D flood modeling and the representation of a simple 1D flood model all the way up to the most complicated type of 1D modeling. So if we start with a river channel, meandering river channel, the most simple type of 1D flood model is going to look something like this, where we have our nodes and we have surveyed cross sections at each node. And basically what's going to happen is a depth, average flow, velocity, and water level will be calculated at each one of these nodes and passed to the next one downstream. This is what we would call an in-bank fluvial model. So this is not looking at any flows in the floodplain or any representation of stuff out of the riverbank. And this is what a flood forecasting model might look like, for example, where we're really trying to focus on what levels are going to be within the channel and when they're going to get there, so we can start actively looking to implement some of those measures like putting in temporary defences or closing floodgates. If we then build this up to the next slide, we can add extended cross sections in our model to start having a bit of a look at considering volume and flows within the floodplain, not just in the channel. And Flood Modeler has lots of useful tools that help you extend cross sections using LiDAR data, so you don't need to send a survey team out to get extensive survey across the whole floodplain. You can have your well-defined channel bathymetry collected by a survey, and then you can use LiDAR to extend the cross sections out. And that is a bit more of a complicated flood model where we're getting some representation of flows in the floodplain. And then if we build that up once more, we have what I would consider the most complicated type of 1D flood modeling. So this is where we have our in-bank fluvial model, and then we use reservoir units or flood cells to accurately represent flows in the floodplain. So what will happen is we'll have our hydraulic inflow up here, water will come through the channel, and once it reaches a certain level, it will go through these spill units and into the reservoir. And then throughout the simulation, the water level in the channel may drop, and then flows from the reservoir can then come back into the fluvial channel. The reservoir units can be generated in Flood Modeler using the tools, and what they represent is a volume versus elevation relationship, and that can all be defined within Flood Modeler. And what this type of modeling allows us to do is to produce flood mapping for 1D only models. So that would be really useful for like the Environment Agency flood maps, for example. So yeah. Quickly just going to run on to some of the advantages and disadvantages of 1D flood modeling. I will say that this isn't a exhaustive list, and there are disadvantages and advantages to every different type of modeling. These are just some of the ones that I've picked out. So typically 1D models, unless they're really, really complicated, will have quite fast run times. So you don't need to wait for ages for the simulation to finish. This is really good for things like flood forecasting, where you need to input data and get really fast results to know what's going to happen in a few hours time. You've got a really good representation of that in-channel water level and flow. And you've also got a great representation of point structures like bridges, weirs, sluices, culverts, and all the other different types of point structures. And some of the cons now. So I'll explain what I mean a bit further by this when I come on to the 2D modeling approach, but your major flow routes need to be defined prior to the model build. We don't have a 2D mesh to determine where water is going to go in the floodplain. We really need to define that. I know I said model runtimes can be fast, but actually setting up complicated 1D flood models can be really time consuming, ensuring that we get ensuring that we get all our structures represented correctly, ensuring that all the data from our survey is correctly input into the model, can be quite time consuming. And 1D flood models can typically not be as good as 2D flood models at representing complex flow routes in urban areas. So that ties into the fact that I said that 1D flood modeling is really good at modeling river channels, but once stuff starts going out into the floodplain, it's not so good at representing the interaction on the floodplain around buildings or flood defences or that type of thing. And also with 1D flood models, we don't get a distribution of velocity in the floodplain or hazard mapping, which can be really useful to inform some of those flood risk management activities that we spoke about before. And the final one I want to touch upon is that to get flood mapping and flood extents out of 1D models, there's some post-processing required, whereas for 2D modeling, those outputs are typically directly output by the model. So what is 2D flood modeling? Building on from that. So effectively it solves 2D equations of flow, which you can think of a bit like an X and Y or an easting and northing. 2D models calculate water depth and depth average velocity on a grid or mesh, like the example that you can see here. And the typical inputs to a 2D hydraulic model are LiDAR data or a digital terrain model, and also in-channel bathymetry if you want to represent the channel as well. With 2D modeling, you can have a simple uniform grid like this one, where you just have one cell size across the entire domain. Or coming soon to Flood Modeler is the process of having a flexible mesh. So this is where you could have differing cell sizes across the domain. So if you have a floodplain that you're not that interested in, you could have a high cell size. And if you have an urban area, you can have a nicely low grid to better represent that urban area. It's also worth noting as well that in 2D models, you can embed 1D structures. So you can embed culverts and you can embed other features like that into the 2D model. I know that was a very quick overview of 2D flood modeling, but I'm just conscious of time. So I'm going to run through quickly some advantages and disadvantages of 2D flood modeling. So like I said before, there's no need to predefine flow routes in the floodplain, because once water comes out of the channel, the digital terrain model, or elevation grid, if you like, takes control of that and determines where water is going to go. As I'll show you in the quick demo at the end, it is very easy to set up 2D flood models and very easy to set up the grid. All you need is some basic input data and you can get going. 2D models are likely to be a lot more accurate for the floodplain, and they will indicate that variation in velocity and hazard mapping on the floodplain. And as I said, before for 1D flood models where you need to do a bit of post-processing to get flood maps and depth grid out of them. Flood maps and depth grids are a direct output of 2D models. Some of the cons I would say is that 2D models can be slower to run than 1D models. So maybe for things like flood forecasting where we need a really quick answer, they're not so good. It's not as good for modeling those point structures and features, but obviously, like I mentioned, you can embed those structures into the 2D domain. So if you have a culvert running through an embankment, for example, you can model that. And a fine grid or mesh or cell size is required for channels to get a good representation of what's going on within the channel, but also urban areas. And increase, if you decrease the grid size, that's going to increase the runtime or the time it takes to do the computations. And the other problem with 2D flood modeling is that it's very data heavy. LiDAR data is usually very large, and some of the other inputs to 2D models and the outputs are usually pretty large as well. So there's definitely a data constraint to running 2D models. And finally, I'm going to touch upon the last type of fluvial modeling, which is a linked 1D, 2D model, which in my opinion is kind of the best of both worlds and is typically what I spend most of my time building. So what we have here is the river channel within our 1D solver, where we have our nodes, cross sections, passing information down to the next one, but we have our floodplain in the 2D. So what happens is we use link lines, as they're called in Flood Modeler, to pass information from the 1D model to the 2D model. So when the water level is high enough in the 1D channel, it will spill over the bank or the red line into the 2D floodplain. And then what happens in the floodplain will be modeled in 2D. And again, like I said, for that complex form of 1D modeling, water can also spill back into the channel. So if water levels in the fluvial channel then drop, or they become lower than the neighboring floodplain, then water will flow back into the channel. And this is really the most common type of flood modeling that I use, and I think is probably the most common type in the industry at the moment. I'm quickly now just going to move on to some rough ideas of when you might want to use a 1D model or a 2D model or a linked 1D, 2D model. Obviously, this is a very rough idea and is very dependent on your study, but just an example, mentioned this before on the presentation, but for a flood forecasting model where we want quick answers as to when water levels are going to get to a certain height, we'll really want a simple in-bank 1D model so that we can determine when flows are going to reach a certain level and start coming out of the channel. If you're doing breach analysis of, say, a coastal defense or a flood defense, you might want to use a 2D model, which is going to well represent the breach and where the water goes once the channel is breached. And for flood mapping or appraisal, we will typically use a linked 1D, 2D modeling approach, which, as I said, is kind of the best of both worlds. It'll give us that really good representation of water levels and flows in the channel, and it will also give us a really good representation of what's going on in the floodplain. I know I've rattled through that, but I have only had half an hour. So I just want to quickly summarize before we move over to looking at the demo. And this is just a bit of a summary slide on what we've covered. So fluvial modeling helps to inform many important aspects of flood risk management, like we've mentioned, flood mapping, planning, appraisal for new schemes. There are many different types of fluvial modeling approaches. Some of them we haven't even been able to touch on today, like 3D models or CFD models. Choosing the right approach for your study is really, really important and can depend on a variety of factors like what data is available, what skills do we have, what is the flood characteristic of the catchment. As I mentioned, I think 1D, 2D link models are becoming the most common approach to fluvial modeling, but obviously I've worked on a variety of different types of models from 1D only to 2D only, so it really does depend on the project that you're doing. And also worth remembering that some projects may need more than one approach. You don't want to pigeonhole yourself into just building one model for one project. You might need to build two models for one project. You might need to adapt your modeling approach throughout the project as things change. And last, Flood Modeler provides robust 1D, 2D, and 2D linked approaches. So yeah, I think quickly before we move on to the demo, Ollie mentioned in his introduction some of our upcoming training courses. So we have our introduction to 1D river modeling, which will go into a lot more detail than I have today on what is 1D river modeling, the technicalities behind it, how we do it, how we build them, how we run them, that type of thing. And we have the same for 2D modeling. And for those of you that maybe are more experienced flood modelers and want to learn about some of the more advanced features that Flood Modeler offers or some of the more advanced theory, we have an advanced Flood Modeler course coming up as well. So that brings us to the end of the slides. I'm going to very quickly jump into Flood Modeler to show you an example of a potential project that you might want to work on. So what I have here is that really complicated 1D modeling approach that I mentioned, where we have reservoir units to model the floodplain and 1D cross sections to model the channel. This model runs through Stockport, is the Upper Mersey, but for my client, which is the Northenden Golf Course, they are wanting to build a new clubhouse and they're wanting to rearrange some of their holes. And currently, the model schematization is not going to allow them to have that really nicely defined representation of flows on the floodplain or velocity distribution or where water is going to go. So we need to change that. So what I've done, and I've done all this prior to the webinar so that I'm not spending time clicking around in the GIS, but I want to show you how simple it is to put together a really quick 1D, 2D model. So if I click over to this stat file, what I've done is removed the representation of the flood cells or reservoir units in the floodplain and the spill units that link to them that collect water from the 1D channel and pass it to the 1D flood cells. So I now have a kind of clean area that I'm going to build my 2D model. First thing I need is some LiDAR data. So that is freely available to download in the UK from the DEFRA website. So I've done that. So we have our nice LiDAR data. As you can see around the golf course, we have this really nicely defined embankment, which is going to act as our control or what water needs to get over to spill into our golf course. I've then come to the 2D build tab and selected active area and drawn an active area which traces nicely along the embankment. So this is our 2D domain or active area. This is where our flooding in the 2D is going to occur. What I've then done is traced a line around the embankment and used Flood Modeler's spill generator to generate a line with points that are going to act as our key control. So this is a line with elevation and points with elevation. And then what I've done is drawn that link line, which you can see on the map, which will act as our spill and our communication between the 1D model and the 2D domain. And then all simply you need to do is build a new 2D simulation. So I've got one here. I've already pre-populated this, but I just wanted to show you how easy it is to build a simple 2D, 1D, 2D link model. So if I go to domains, I've dropped my LiDAR and my spill levels in the topography section. I've defined my active area here, and here you can change the grid size. So if you need a really fine grid size, like 1 meter cells, you can change that here. And I've changed the time step. And then all I've done is link it to my 1D IEF file and added my 1D, 2D link shape files in here. And that really is how simple it is to set up a 1D, 2D link model in Flood Modeler.